All right, here we are, day 2 of our initial study of functions, which I have told you is the focal concept of the entire class. What we are in this class are function writers. Often I will tell you explicitly the functions that I wish you to write, but even when I don't, you will write functions, many of them, and then ultimately the code that you will turn into me will just simply be collections of functions. That's how we solve problems in this class. Now, if you take a look at the code editor, you see the function that we wrote last time. So we'll use it in just a moment. I won't talk through it again. Instead, what I think I'll do is this, is I'll write another function to go along with it. And this function will have actually multiple parameters. Remember that I said that the variables that are contained, possibly many of them, in parentheses after the function name on the header line, those are called the parameters of the function. So let's write a function that has multiple parameters, and then we'll talk through sort of the basics of functions again, because I think it's really important for you to hear that story more than once. All right, here we go. So let us begin to write a second function. So how does that start? DEF, every function begins with the keyword DEF, and then we need the name of the function. Well, I've made a decision for us. Let us write a midpoint function. I'm also a teacher of geometry, so our examples are often geometrical in nature. So let us write a midpoint function. And then what would be a good way to spell this? You know, it shouldn't be like A or B or X or Y or something like that, though Python wouldn't care. Those are perfectly acceptable names. As always, we wish to choose names that describe the object named. So this is a function that computes midpoint. So how about MDPT? I think that people would understand that that is midpoint. It would also, of course, be perfectly acceptable to write out MIDPOINT. If you find that clear, then by all means do that. You could also write out something like this underscore function underscore computes underscore midpoints or something like that, or even longer if you like. Now, at that point, I mean, that's extraordinarily clear, of course, but it's also ridiculously long. And it's not really any clearer than just midpoint. And then, I mean, who wants to type that out again and again and again every time you wish to make use of the function? Anyway, so I think MDPT is fine. Now, let's think about this. Oh, and maybe if you haven't encountered the midpoint formula in geometry, you'll want to pause and do a Google search and take a look at that. So, do that if you need to. So I assume now that you understand what the midpoint function is mathematically. And what it needs to do its work is 2 points. Okay, and you know how points are specified? Points are specified by a pair of coordinates, an x coordinate and a y coordinate. So we need 2 points, each specified with 2 coordinates. So we need 4 total values. Usually those are represented as x1, y1, those are the coordinates of our first point, and then x2 and y2. So let's pause there and talk about what we've got, just again to review the basics of functions. So this is the header of a function, which always begins with the keyboard DEF. After that comes the name of the function, which is our choice, right? We just simply have to obey the usual rules of name formation, letters, numbers, and underscore, no number first, and then open parenthesis always. And then after that comes the list of parameters separated by commas. In our first function, the square function, we only had one parameter, that is, we only need one input value to square, but the midpoint formula actually requires 4 input values. Uh, excuse me, the coordinates of the first point, x1, y1, and the coordinates of the second point, x2, y2. Okay, so, oh, and then of course, finally, we end up with the colon on the header. And you know what the colon indicates, right? The colon indicates that underneath we will indent, and so we'll have a grouped block of code. And that's always the case. Colons don't occur only in functions. We'll see them in many other contexts as well, but they always mean the same in Python. A colon only ever comes at the end of a line, and that it then indicates that what comes next is a grouped block of code, perhaps just one line, but in many cases, multiple lines. All right, so I hit return, and our code editor has been kind to us. It is automatically indented by 2 spaces. So let us actually get the x coordinate of the midpoint. So what is the x coordinate of the midpoint? You get that by adding the x coordinates and dividing by 2. And that right there, as written, is, do you remember I talked about stop and go bugs? And go bugs are bugs where the code will actually execute but get wrong answers. Well, if I left it like that, that would be a go bug. You do understand the problem, don't you? Because what this would do is it would take x2 and divide by 2 first, and then add that to x1. That is the usual order of operations, and Python follows that. follows that. So instead, what we wish to do is to do the sum of x1 and x2, and then after the sum has been created, we wish to divide by 2. And so we now need the y-coordinate of the midpoint, so it will be the same kind of procedure as well. So let us go y1 plus y2 divided by 2. And notice that I have put the spaces in there. I think it makes it much more readable. And then what do we wish to do? We wish to return both of these values. Okay. And this is not something about which we will talk extensively at this moment in time, but it is certainly possible to return multiple values. And if you mean to return multiple values, you simply separate them by a comma. Okay. And we will need to talk about how you will handle a return value like that. But we won't need to handle it. We'll only see it. So this is perfectly fine for now. All right. So let us hit the run button. Oh, so far so good. No crashes, no stop bugs, which is good. But we haven't yet executed the function to verify that it does seem to be correct. So you remember how we execute the function, right? We don't simply type in the name of the function. I mean, we could. That's perfectly syntactically correct. And Python reports back to us that, yes, that is a function. Instead, if we wish to execute the function, we have to give it values for x1, y1, x2, and y2. So let's say that our first point is 0, 0, and our second point is 4, 4. Now, I chose an example here that is deliberately simple because I want to be able to verify that my function is correct, at least with some simple cases. So I do believe that the midpoint should be at 2, comma 2. Oh, yeah, there it is. It's actually nicely printed out for us, 2.0, comma 2.0. So that does seem to be correct. And I can try another one out, though honestly, I don't independently know what the value of this should be. So I expect it will be correct. Okay, so there's where the midpoint is for the point 1, comma negative 12, and the second point 6, comma 7. The midpoint is at 3.5, comma negative 2.5. Okay, so we have then that same kind of structure that we saw last time, right? We have the function itself, which goes from lines 5 to 6 to 7 to 8. Line number 5 is the header, 6, 7, and 8 is the body, and the body, it's all indented the same amount for us here in REPL, that is 2 spaces. Then we called the function. And when we call the function, we have the function name followed by parentheses. And then inside of parentheses, excuse me, we have values that we will send to the parameters. So on that second function call, 1 became the value of x1, negative 12 became the value of y1, 6 became the value of x2, 7 became the value of y2, and then the body of the function was executed. That is line 6, 7, and 8 were executed. And then what was printed in the console was the value that is returned. Okay, because the value of a function call is the value that is returned. So that once again is the basics of a function. And notice something here, right? Notice that we have a different, here's the term, flow of control from what we had in the previous chapter. And here's what I mean by that. In the previous chapter, we wrote some simple programs, right? And you had to write one, what will seem to you fairly lengthy program. But the way the program worked is this. When you hit the run button, it went up to the top of the program, executed the first line of code, and then the second line, and then the third line, and then the fourth line, and so on, and worked its way all the way down to the bottom. That is just straight top to bottom, just like you, for instance, read a book. However, in this case, we didn't have that kind of flow of control, right? So we first of all hit the run button, and then Python actually, set up the functions in memory, so it knew how to call them, and then we called the function, right? So like midpoint 0044, well, that executed lines 6, 7, and 8, right? And then when I called midpoint again, it executed lines 6, 7, and 8 again, right? So we didn't have this sort of strict top to bottom execution. Instead, when we call the function, we execute only those lines of code that are contained within the function, and we can call the function multiple times. So we could like call the function once and do lines 6, 7, and 8, and then call it again, which means flow of control pops back up to 6 and then goes down to 7 and 8 again. So I just did want to point out to you, this is very intuitive given the work that we've done, but I did want to point out to you that it's not, of course, inevitable that when you write code, it just simply executes from top to bottom. There are ways to control that flow of which lines get executed. And one way to do that is to create a function and call the function multiple times.